Hello, everyone. Welcome back to today's lessons. I'm excited again to be on your screen, and my friends around the world. I say thank you so much for your support, for your like, for subscribing to my YouTube channel, for my TikTok account, and all. I say a very big thank you to you guys. You guys are the best. My students, my friends around the world. You guys are the best. Now, in today's video, I'm going to be taking you into a very good journey on Nernst equation and how to apply it in getting the electrode potential of a cell. Now, on the board is a good question for students preparing for A-level exams, for Cambridge A-level exams, for NEET exam, for JEE exams, and other advanced A-level exams. Now the question says, write the next equation and calculate the EMF of the cell at 298 Kelvin. Please, this word should be underlined, 298 Kelvin. Because at 298 Kelvin, the next equation you have to use is this, whereby the electrode potential of the cell is equal to the standard electrode potential of the cell minus 0.0591 over n log of the product concentration over the reactant what concentration. This n here simply tells you the number of electrons that are involved in the reaction, which you will see here. So what do? I break it down in stepwisely. So I come here. Of course, this is simply the reaction cell, whereby magnesium, like normally the way it is like this: magnesium, right, which is from 0 to +2, right? This is the salt bridge. This double line is salt bridge, which I've told you before in my previous video. So at the anode now, right, magnesium down to what now? Magnesium 2+, right? While at the cathode now, you are having copper 2 ion to copper, right? Now the net equation, please take note, from 0 to +2 for oxidation, electrons are always balanced. I always used to balance the reaction in the right hand side. So here become 2E minus. While for reduction, here is also 2E minus. So at the end of the day, this one cancels this one. The overall becomes Mg plus this will give me magnesium ion plus copper. Is that clear now? So actually it's very, very simple. Now what do we do next? We calculate for the what now? Electrode potential of the cell. Remember, the formula is electrode potential of the cell, which is standard, is equal to the electrode of the cathode, right, minus what now? The anode. For you to use next equation, you must have already confirmed whether the reaction is feasible or not. If it's not feasible, you cannot go ahead with the calculation. So you come back to say, at the cathode now, the cathode, since reduction, okay, at the cathode, what do we do? Okay, cathode here now is copper. We use reduction. This is reduction, right? So which is this one? This is 0.34 minus bracket what now? Minus 2.37. So when you subtract, you should be having it to be what now? 0.34 plus 2.37. So the final answer here for the electrode potential is 2.71 volts. Remember, minus and minus is plus. So I've gotten for this one, so we can now use the what now? This formula. Please take note of this stuff. So permit me to rub this top here and leave the other parts. Okay, very, very simple. So I move here to say the E of the cell is equal to, the standard electrode potential is 2.71 minus 0.0591 over, now take note, the N here simply stands for the number of electrons at the balance end. So it is 2. Remember that you have 2 here, you have 2 here. And even this electron here and here, they were not balanced. You have balanced it first before you use it. So here is 2. Now log that of the product here now. Is it not, for the product here, is it not magnesium you have here? You pick only the ions. So magnesium ion here is 0.001 over that of the copper 2 ion here, which is this one here, is 0.0001. So let me erase the board. Okay, which is now equal to, if you do everything once with your calculator, you just, without wasting time, it will be 2.71 minus, okay, 0.0591 divided by 2. Move to log concentration of 0.001 divided by 0.0001, right? So the final answer here is plus 2.68045 volt. Final answer. You observe here, the reason why we're able to use next equation was because we see that the reaction from the electrode potential was positive. So it is feasible. So this is the final answer using next equation. You should know how we got these two. It means the electron balancing, the electrons that are involved are balanced before you can use it. If here was 2 and here was 3, you cannot do it like that. You have to multiply, you have to exchange the electrons by saying, let's say I'm having 2 here, I'm having 3 here. For you to make these 2 electrons here and this 3 electron here to be equal, so you can use it, you just multiply here by 3 and here by 2, and here will give me 6 electrons, here will give me 6 electrons. So I cannot use, so the common electrons now cannot be 6. But hence that this here was 2, here was 2, I just picked one of them. Is that clear? So this marks the end of our calculations on that next equation. See you in my next video. Thank you and God bless you.